Probably. We'll see. Now, are there any questions over the assignments before we finish up the chapter 5.7 notes? Okay. So I know this is the problem we stopped on yesterday, looking at this function here and determining if it has an inverse and then finding it. Because we did this problem here and found that f inverse of x, a little bit smaller pen, is equal to x squared over 4 plus 3. And this is the function that we got. So we'll look at one more of these here and a few more finding inverses, just so we kind of gotten used to it and seen a few. I think your guys are pretty comfortable with it, but we'll still look at a few. Now, our first main step in finding the inverse is to rewrite or replace f of x with y. Our second step is to switch x and y. Our third step is to solve for y. And then fourth is to replace or rewrite y as f inverse of x. And these are the steps that we got yesterday. But yesterday I didn't write them in kind of a shorthand notation. That took a bounce. So, looking at this here, this function, f of x equals 3 times the square root of x plus 4. Well, the first thing we can do is replace f of x with y equals 3 square root of x plus 4. Then our next step was to switch x and y. So x is equal to 3 times the square root of y plus 4. Then the next step was to solve for y. So what's the first thing we can do in solving for y? Divide both sides by 3. Because 3 divided by 3 will simplify to 1. Telling us that we have x over 3 is equal to the square root of y plus 4. Now what do we need to do next? We need to square both sides. Okay. Okay. I don't know how it associated something with the pen. There we go. Squaring both sides. Now when we square both sides, on the left-hand side, x squared would be on top over 9 is equal to y plus 4. And the last thing we would need to do is to subtract 4 from both sides. And when you subtract 4 from both sides, we get that y is equal to x squared over 9 minus 4. So our inverse function, f inverse of x, is equal to x squared over 9 minus 4. And that right there would be the inverse function. Questions on any of these here? Now, I'm not going to have y'all graph these or look at actually do the graphing. I mainly focus on y'all being able to find the inverse of the function. Any questions on this here? Any questions on anything we've done so far? All right. We'll look at this one here and kind of one or two more, and then we'll move on to the last part. Now we look at this one here. What's our first step? Well, we replace f of x with y. Y equals negative x cubed plus 4. And then we would switch x and y. Now, the step that I wrote in red where we replace f of x with y, if that is something that is necessary, that helps you solve these and keep these straight, write it. Go on and put it down. But if going straight to the one that I wrote in black makes sense, the fact that it is f of x is y, we know that, and we're switching it, I can do both of those in one step. So we just go on, instead of rewriting or writing the one in red, we can go straight to x equals y cubed, negative y cubed plus 4. We can go straight to that. We don't have to write the step in red if you don't need it. If it's not something that helps you process through this problem. Now we need to solve for y. What can we do first? We can subtract 4 from both sides. And when we subtract 4 from both sides, we'll get x minus 4 equals negative y cubed. Yes? What would we do next? We'd multiply by negative 1. We would divide by negative 1. We're changing the sign for y cubed from negative to positive. Because sometimes it's easier to see the multiplication of negative 1 over the addition and subtraction, or the division of negative 1. But really, I'm taking y cubed from being negative to positive. I changed its sign, which means the signs on the other side have to change. So since the x is positive, it's going to become negative. Since the 4 was negative, it's now positive. And last but not least, we cube root both sides. Luckily for us, the cubed root's only one solution, so we don't have to worry about plus or minus, and this is it. And we're left with the cubed root of negative x plus 4. And for our notation, f inverse of x equals the cubed root of negative x plus 4. Any questions on this here? All right, let's look at the last part. Verify that f of x equals 3x minus 1 and g of x equals x plus 1 divided by 3 are inverses. We want to verify that this is true. There's two ways we can go about it. One is I can take f of x or g of x and determine what its inverse is, actually find it like we've been doing. There is another way. and that's using our composite function, f of g of x. And g of f of x. Using these functions here can actually help us find the inverse. Well, not find it, determine if these are inverses. Now, before we dig into this, I'm going to draw another picture. As we've been talking about, and I've been showing again and again, our domain and range, yes? And our f of x function takes an x value and maps it to a specific y value, yes? Then our inverse function, if we do have inverse of f of x, f inverse of x takes it from that given y value back to its corresponding x, yes? Because the inverse undoes itself. Now, for this here, what we're looking at, I'm not going to call this f of x anymore. I'm going to say g of x. Because if these two are inverses, and we look at, say, f or g of f of x first. Well, as we worked the other day, working from the inside out, if I plug that x value into f of x, it's going to take me to this specific y value, yes? So this is just saying g of y. Well, if it is an inverse, it's going to take me from that y back to the x, just telling me that this is x. Well, if we go the other direction, f of g of x, and these are inverses, well, it's going to take me from this x value along g of x to y, which is f of y. But that y value should take me right back to x, because it's mapping those points from one to the other. It's just going in the other direction. So if two functions are inverses, f of g of x and g of f of x should be the same. And their actual value should be x. Because if I'm taking the x value to the y and then right back to the x, f of g of x and g of f of x should just be x. They should undo each other. So if I have two functions that are inverses, f of g of x and g of f of x should both come out to be x. Now if we look at f of g of x, what is our g of x function? X plus 1 over 3. Okay. Now our f of x is 3x minus 1. Well, we don't have f of x anymore. We have f of x plus 1 over 3, yes? So we'll plug this, highlighter, x plus 1 divided by 3 in for x, which is going to give us 3 times x plus 1 over 3 minus 1. What do I know about the 3 and the division of 3? They'll cancel out. Now I'm going to write this step out just so we can see it, because when we multiply a whole number by a fraction, it always multiplies with the numerator. So what I'm saying here is I have 3 times x plus 1 over 3. Anytime we have something divided by itself, it reduces to 1. So what we have here is x plus 1 minus 1, which is x. So f of g of x reduces to x. This here is equal to, well, apparently I'm going to scroll. Is equal to x. Now we're going to look at g of f of x. We're going to go the other way. Well, we know what f of x is. F of x is our 3x minus 1, yes? And again, we're plugging 3x minus 1 in for x and g of x, which would give us 3x minus 1 plus 1 divided by 3. Yes. Because it's really boiling down to there's something I'm doing inadvertently, some gesture that I don't know what it is, and that's more frustrating than anything. Not yet. Now the -1 plus 1 would cancel out, giving us 3x over 3, which is x. So g of f of x is equal to x, telling us that f of g of x is equal to g of f of x, which is x. So we can say that these two are inverses. They're inverses of each other. And there's another reason we knew that these were going to be inverses. So, as I just said, I mean, there's one way we kind of knew that these were going to be inverses, as actually was told to us in the directions. It asked us to verify, because if it's asking us to verify, it's really another way to say to show that these are inverses. So it kind of told us that they were going to be inverses. Yeah, because verify, show that they are. Now, these here, most of the ones we'll do in Algebra 2, this isn't bad. Doing this is not bad. Once we get into the pre-calculus class, and we start looking at some of the cubic and quadratic that have multiple terms, and it's asking us to verify and show those, it gets a little more complicated because we have more things that we're having to plug in. We're having to deal with square roots and fractions. Those, it's sometimes easier to just pick one, find its inverse, and see, does it match up with the other equation? But most of the ones we'll do in here are actually pretty nice. I'm going to skip that. I'm going to look at this one because this one here is so straightforward. Now, this one here, are we guaranteed that these are going to be inverses? No, because what does it say in the directions? Determine. So it could be yes, it could be no. So let's look at f of g of x. I'm just going to pick one of them. Now, if one of these two does not give us x, we know that they're not inverses. Because for them to be inverses, f of g of x and g of f of x have to give us the same thing. And more specifically, it has to give us x. Now for this here, g of x is x minus 5. So so now we have f of x minus 5. And to plug it into our first function, we're going to place x with plus 5, which is x. Okay, so that worked out so far. Now we just need to do it the other way around and look at g of f of x. Well, f of x is, and if we plug it into g of x, we would have x plus 5 minus 5, which equals x. So are they inverses? Yes. F of g of x is equal to g of f of x is equal to x. And that's all we have to do. I think we're closing in on the end. I think this might be the last one where we're going to look at, yes? So, f of x is 8 times x squared, and g of x is the cubed root of 2 times x. So, let's look at f of g of x first. And again, I just pick one at either one of the two to do first. Normally, I just stick with f of g of x first. Now, g of x is our cubed root of 2x. So we're taking 8 Well, now we plug this into f of x. So replacing the x cubed, the x with our cubed root of 2x. So we'll have 8 times the cubed root of 2x cubed. Well, the cubed and the cubed root will cancel each other out, yes? Leaving us with 8 times 2x, which is 16x. Is that what we wanted? No, we needed it to be what? Just x, yes? So, not inverses. And we could show the other way around, g of f of x, because that would give us g times 8, g of 8x cubed, not times. And then we'd have the cubed root of 2 times 8x cubed. Well, 8 times 2 is 16x cubed. Now, we know that we can take the cubed root of x cubed. That works out fine. Well, 16 is 4 times 4, or 2 to the 4th, which means I can bring 1, 2 out, but I'm still left with the cubed root of 2, because 16 is not a cube. It's not a perfect cube. It's a perfect 4th power, because 2 to the 4th is 16. So these here definitely don't give us the same thing. Now, the main way we could change this is if 1, that 2 is not a 2, but a half. Was a half, because here we would have gotten 1/2 times x, or no, it wouldn't be a half, because it'd be something else, because the numbers are slightly off to get this right, because the numbers don't work out. Because for f of x, well, we would divide by 8 and take the cubed root, which would have been the cubed root of x over 2. So, if I can write, yep, to the wrong side. So g of x for this here really should have been the cubed root of x over 2. Because when we cube this, the cubed root and the cube on top would cancel out, but we would still cube the 2 on bottom. 2 cubed is 8. 8 times 1/8 is 1, so it just leaves us with x. When we do it the other way, well, we would have the cubed root of x to the 3rd on top. Well, the cubed root of 8 is 2. The cubed root of x to the 3rd is x, and it would have been over 2. Our 2 over 2 would cancel. So this here, that's kind of why it doesn't work, because g of x really needed to be the cubed root of x over 2, not 2 times x. But did it ask us to find out what the inverse should be? No. That's just kind of over and above, just kind of showing you what it should have been if it was going to work. Y'all ready for the next slide? Page 289. Flip it around. So this is your assignment here. I went on and took out the ones that we started the lesson with yesterday. So the ones where it's solve the equation for x and then find the input when the output is given, da 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 da. I took those out. Those aren't going to be on the test. I find those really weird. So it's mainly going to be finding inverses and then kind of determining if the two are indeed inverses of each other. Any place where it says graph, we're not graphing. We're not graphing. Because again, the only time I will ask you will need to graph is if I specifically state that you need to graph. But most likely I'm not, because we have way too many tools now that will graph for us. And the most we need is kind of an understanding of what the graph should look like, not exactly 100% how to actually do it.